All right, let's step right out of the theoretical textbooks and onto a gritty dirt lot in Virginia Beach. Picture this with me, a high-contrast industrial laboratory bathed in the harsh, glaring light of halogen bulbs, with a massive, dedicated electrical substation just humming away in the background. In this explainer, we are looking at a truly cinematic quest to completely break the boring, conventional laws of standard rocket propulsion. What we're diving into today is a manifesto that details the creation of the topologically asymmetric field-coupled mode, or, as it's affectionately called when the cameras are off, the flying donut. The source material makes an audaciously blunt claim right out of the gate, and I absolutely love it. It states that standard plasma propulsion is literally philosophically offensive. Why? Well, because it's just incredibly wasteful. Think about it. In a standard rocket, you heat up a gas, you run it through a symmetric magnetic nozzle, and you spit it out. But in doing so, half of your energy goes straight into useless radial expansion. You're constantly fighting the isotropic nature of expanding gas. You just sit there getting incredibly hot, looking mathematically stupid, and burning through propellant in a perfectly symmetric sphere. We don't want to fight nature here, we want to trick her. The contrast between these two approaches is just striking. On one side, you've got standard symmetric rockets just throwing away all that radial energy. On the other, we have the beautifully biased, directed momentum of the TAFCAM trefoil knot. Look, to get real efficient propulsion, you can't just build a lopsided rocket. You have to bias the momentum at a fundamental physical level. You have to introduce topological asymmetry. So instead of a symmetric exhaust plume, we're looking at winding a magnetic field into a continuous interlocking 3D torus knot. This acts as a momentum exchanger with a local vacuum itself. So that brings us to the absolutely crucial question. How do we actually trick nature into breaking mirror symmetry? If we want to move forward without just throwing a massive amount of mass perfectly backwards, we need to bend the mathematical laws of the universe to our advantage. We need a shape that nature looks at in the mirror and sees as fundamentally, undeniably different from its reflection. And the answer to that puzzle lies in a mind-bending property of geometry. The foundational secret weapon to pulling this off is chirality, or handedness. The specific topology used in this project is a T32 knot, which is also known as a trefoil knot. It wraps around a torus 3 times in the longitudinal direction and 2 times in the meridional direction. Now, the absolute magic of the trefoil is that it's inherently chiral. You have a left-handed trefoil and a right-handed trefoil, and you can never, ever deform one into the other. It shatters mirror symmetry or parity right out of the gate. So what happens when you take a plasma, a boiling, chaotic soup of electrons and ions, and confine it inside this magnetic trefoil knot? You inject magnetic helicity right into your system. And the specific magnetic helicity linking number here is exactly 6. You have topologically locked a mathematical twist directly into the plasma. And in a highly conducting plasma, helicity is a conserved quantity. Nature absolutely hates an unbalanced twist, but the strict mathematics of the universe forces her to conserve that linking number of 6. Which brings us to the actual mechanism of action. When that knotted, screaming magnetic vortex tries to expand out into the vacuum, topological constraints force it to undergo an incredibly violent unwinding process. Step 1, the primary stator coils squeeze the knotted plasma. Step 2, as it's forced out, those topological constraints are violated, which triggers massive magnetic reconnection to detach the plasmoid. And step 3, because that original knot was chiral, the magnetic field lines snap and reconfigure asymmetrically. This delivers a massive directional momentum transfer, a heavily biased kick directly to the ship's superconducting coils. And that, right there, is what we call anisotropic recoil. The energy release simply cannot unwind equally in all directions. The chirality forces the plasma to squirt out almost like a twisted, wet towel being violently wrung dry by the laws of physics. The snapping creates this massive burst of alpha waves. And because the field lines are still momentarily anchored to the ship, that explosion travels back up, delivering real physical thrust to the structure of the craft. You are literally squeezing thrust out of a broken mirror. Now, obviously, building a 60-foot nuclear-powered craft on day 1 is a fantastic recipe for a disaster. So the manifesto outlines a brilliant Phase 1 benchtop roadmap. The original theoretical documents called for liquid lithium heated to 600 degrees Celsius. That is a pyrophoric nightmare that will catch fire if you so much as look at it wrong. Thankfully, for the benchtop test, they swapped that explosive hazard out for gallium. Gallium is a room-temperature liquid metal alloy made of gallium, indium, and tin. It looks exactly like liquid chrome, it's highly conductive, and it allows the researchers to test those exact same Lorentz body forces without needing to hide in an argon-filled bunker. And let me tell you, the physics holds up beautifully. Just look at this number, 3,380. That is the Hartman number they achieved with a gallon stand flowing through a clear acrylic channel under a 5 Tesla magnetic field. To put that into plain English, the magnetic field is gripping the liquid metal's electrons so tightly that it completely crushes the fluid's ability to be turbulent. It forces the fluid into a perfectly laminar, solid plug flow. The fluid isn't just flowing anymore, it's practically being dragged as a single unified block by Maxwell's equations. To actually generate those immense 5 Tesla fields, the design uses high-temperature superconducting tapes. We're talking about glowing REBCO coils chilling at a frosty 20 Kelvin. These specific superpower SCS 4050 tapes operate with a massive safety margin. And why does that matter? Well, because they use a no-insulation winding technique that gives them built-in quench protection. Basically, if there's a localized hotspot, the current safely bypasses resistive turns via turn-to-turn contact. It gives them the immense magnetic grip they need without accidentally blowing up the lab. But of course, no highly ambitious engineering project is ever complete without some absurd corporate bureaucracy, right? I absolutely love this part of the source notes. The local human resources department actually sent a memo to the lab complaining that breaking mirror symmetry and relying on anisotropic violent energy release creates get this, a hostile work environment for parity-compliant plasma. They seriously requested the engineering team redesign the coils to be perfectly symmetrical to foster a fair environment, and even suggested they rename the device the Wellness Torus. You can't make this stuff up. The contrast here between HR compliance and actual quantum reality is just hilarious. Because of all these insurance mandates, you literally have 5 terrified graduate students walking out onto this dirt lot wearing level A hazardous material suits, thick rubber aprons, and double-layered face shields. And what are they doing in all that gear? They're just walking over to an IBM server to run some quantum math equations on a digital terminal. I mean, the biggest threat to this mission isn't the complex plasma physics, it's HR trying to enforce parity on a chiral universe. Anyway, those poor grad students in their rubber suits were out there to execute something called the Kookaburra seed. You see, you can't just guess the phase angles for a continuous T32 trefoil magnetic field distribution. If you let a standard quantum approximate optimization algorithm, or QOA, just wander around blind, it'll get totally stuck in barren plateaus. The Kookaburra seed is a specific warm start initialization protocol. It basically drops the quantum optimizer directly into the exact mathematical value where the topological constraints perfectly balance the magnetic stress tensor. The exact telemetry they locked in really tells the story here. Layer 1 uses a gamma of 0.400 and a beta of 2.575. Layer 2 then shifts to a gamma of 0.679 and a beta of 2.827. By hard-coding these precise angles into the local simulator, the quantum gateway calculates the optimal nonlinear current distribution across those coils to break mirror symmetry flawlessly, all without blowing out the containment seals. It is a showcase of elite technical precision, working in direct defiance of HR's demand for balance. So all the pieces are finally in place for the live benchtop firing. The timeline is locked. First, the cryocoolers drop the REBCO coils all the way down to 20.1 Kelvin, getting them nice and frosty. Second, the Kookaburra seed initializes the quantum gateway, locking in that chiral magnetic topology we just talked about. And finally, the moment of truth, the closure of the high-voltage relay to dump electrical current straight into the Galveston loop. I want you to set the scene in your mind right now. The entire Virginia Beach lab goes quiet. The only sound left is this low, immense, chest-vibrating 60 hertz hum coming from the dedicated electrical substation. As the notes vividly describe, it is literally the sound of raw, cosmic energy routed straight from the grid, just waiting to be unleashed. The voltage is sitting right at 12.5 kilovolts. The air is thick with tension. And then the high-voltage relay closes. No mechanical pumps, no spinning fan blades kicking in, just raw current instantly flowing through that shimmering loop of liquid metal. The magnetic field says hello, and the Lorentz body force reaches out its invisible fingers, grabbing those Galveston ions right by the scruff of the neck and shoving them sideways. The liquid metal begins to crawl around the acrylic loop, perfectly and silently obeying Maxwell's equations. Then, the data starts pouring in. The piezoelectric load cells attached to the frame don't just rattle, they spike hard. They register exactly 14.28 newtons of pure, undeniable directional topological recoil. No exhaust plume, no propellant burnt away to absolutely nothing. The physical frame of the rig absorbs an anisotropic kick exactly as the math predicted. Symmetry is officially broken, and directional thrust is achieved. I want to leave you with this final, absolutely provocative thought directly from the Manifesto. The Navier-Stokes equations?
They don't care about your funding deck. And nature certainly doesn't care about HR's demand for a symmetrical, fair workplace. Maxwell's equations just want to know if you are brave enough to wire up the loop and actually turn the dial. Well, they turned the dial, and the needle moved. So it really makes you wonder, what other impossible concepts are just waiting out there for the right mathematical twist? Thanks for joining me on this explainer. Stay curious, everyone.